In this video, we will use the fundamental theorem of algebra to factorize a cubic polynomial given one of its roots. The fundamental theorem of algebra states that a complex polynomial of degree n has n complex roots such that f of z can be factorized as a(n) times the product of z minus the first root times z minus the second root up to z minus the nth root. Consider the following problem. Suppose z equals 1 is a root of the cubic polynomial z cubed minus 3z squared plus 7z minus 5. Factorize the polynomial accordingly. By the fundamental theorem of algebra, we know there are three roots, and we can express the polynomial as z minus 1 times z minus w2 times z minus w3, where w2 and w3 are the remaining roots. Since we already know one root, we can factor out z minus 1. This leaves us with the quadratic z squared minus 2z plus 5. We set this equal to 0 and solve using the quadratic formula. First, let's find the discriminant. Negative 2 squared minus 4 times 1 times 5 gives negative 16. Then the square root of the discriminant is 4i. Now w2 equals 2 plus 4i all over 2, which simplifies to 1 plus 2i. The remaining root w3 equals 2 minus 4i all over 2, simplifying to 1 minus 2i. We now have all the roots of the polynomial, and we can write its fully factored form as g of z equals z minus 1 times z minus 1 plus 2i times z minus 1 minus 2i. This concludes the example. Thanks for watching.